Greetings. Thank you for joining this month's Building Smart USA webinar. We'll get started with Michael in just a few minutes. It takes a minute or two for folks to be able to log in, and when we see the numbers stabilize, we'll get going with the real content. You'll be quite excited. It's amazing what Michael is going to present in terms of being able to verify the models and the power of open standards. Will be started in just a minute. Okay, it looks like our logins, well, actually, we still have people logging in and joining, but there's so much content to cover. We want to make sure that Michael and Connor both have time to not only do their presentations, but to be able to have a question and answer session later. So maybe, Michael, can we start with you? And then you can hand over to Connor at the appropriate moment.
Sure thing. I'm sharing my screen. That should be visible to everybody. Is it coming through clear?
Looks really good. Yeah, very crisp.
Excellent. So thank you for joining today, and thanks for the time, guys. Connor and I have a great presentation for the use of openBIM and what we do with openBIM and the benefits behind utilizing openBIM and how we use it in our industries. To introduce the agenda for myself, there'll be a brief introduction about me, a brief introduction about AECOM. I will go over the data architectures behind openBIM uses, and then I will discuss the benefits of openBIM and then talk about some openBIM enhancement recommendations. And then I will be doing a project sample demonstration using Celebri. So hopefully this all goes smooth and the transitions work out well. So my name is Michael Warren. I work for AECOM. I'm situated out of the Philadelphia office. I'm the Associate Vice President and BIM Director for Transportation. My day-to-day oversights or income is to the company is brought through a market segment called Digital Practice and Technology, where I focus on innovation. And what that means in the long and the short of it is taking software and data and utilizing them in a comprehensive manner so that you've all heard this before, the single source of truth never gets lost, but it's interchanged between software platforms and ownership or retention of that source of truth is maintained. I get very creative. I'm a programmer. I'm a graduate from Carnegie Mellon University, architect by profession, but moved into transportation because I've been involved in BIM for over 30 years. And as the infrastructure world is growing with the use of BIM, AECOM saw a benefit and a need for me to be there. So with that, about AECOM, I'm sure everyone on the call knows who we are, but the stats are listed there just in brief on the screen. I'm not going to go through them. But the important thing is the 52,000 employees worldwide. It's a very large network of professionals and expertise that keep us moving and keep us going to be number one in transportation, general building, and international markets. And that's based off of ENR. It's a fantastic place to work. I enjoy working here. I love my collaboration every day, the thoughtful insights that I get, and the recommendations I get for improvements or enhancements on what we do. So we always have a value moment, and I want to bring a value moment to this council. Before you become too entranced with gorgeous gadgets and mesmerizing video displays, Let me remind you that information is not knowledge, knowledge is not wisdom, and wisdom is not foresight. Each grows out of the other, and we need them all. So for the science fiction people in the room, Arthur C. Clarke, that's a quote from him. But what does it mean? It means this. The quote emphasizes the importance of understanding the distinction between those areas: information, knowledge, wisdom, and foresight. I live by these every day, and they're sort of my metrics whenever I go about pursuing interoperability between softwares and the models that we use. It's good for a well-rounded understanding. Because I work in infrastructure, it's important to understand the world and how we build digital twins or are going about building digital twins, which we're not going to discuss today, but is an open topic for everyone. So let's get right into it. The data architectures behind openBIM and uses. Who's familiar with an XSD file? The important thing about XSD is it's the schema definition behind XML. We probably all use XML or encounter XML in our day-to-day functions, but what's important are the 5 steps that are written there: the validation, the elements and attributes, the relationships, the data storage, and then how we actually write it in XML. It's a crucial role for XSD to define the structure and the constraints of the XMLs that we write. These are the governing body of rules, okay? And they validate the XML. So while you're writing XML, if you're not using XSD files, I highly recommend it. It's a nice container, a nice hierarchy to build out openBIM strategies with what you're doing. An XML file, not going to get deep into it, but it has a purpose and a definition. It can be compared with HTML, but they have 2 completely different functions, which I'm not going to go into, but XML is a data-rich description language, okay? And HTML is predefined and is limited with markup symbols. And then there's some common uses I list on the screen for XML files: RSS and Atom feeds, Microsoft.NET configurations, small databases, UI layouts, and Android applications. So here's an example of a schema in XML that's validated and put into our XSD format. This started with the original schema that came from the software and then was developed. To tell everybody to do this, you have to have a programming background or an understanding of it, but you can use samples that come from the software that you use to build on these classes and definitions that you're checking and looking for. The vendors have worked very closely with Building Smart to develop this information, and it's very key to have an understanding of these as you develop and enhance your own schemas we're working through. There are tens of thousands of lines for a very robust XML schema. I don't recommend that for every project. It's scalable and sizable based on what you're doing. JSON is another opportunity that we can take advantage of inside the openBIM environment. It is structured data, okay? And it has widespread adoption in programming, and it's a go-to choice for that schema of getting model and data information out. So there's data exchange with APIs, RESTful services, and front to back-end interactions. Storage and configuration has to be configured. Web development has to be configured for easy visualization and viewing of very data-rich models that don't take a lot of computing power. That leads right into mobile apps. And then there's the public data exports, which a lot of us will find on GitHub or other locations with regard to open information for openBIM. In design software, I found that pset files or property sets are good for customization. These are written inside and used by your applications that enhance data that come out from the openBIM. Basically, what I'm talking about is additional property sets that go into the IFC model when written correctly, and your IFC schema for export is updated with customized IFC attributes. You get property sets, you have the customization, you want to include additional attributes on objects, and I'm going to demonstrate that at the end of my presentation based on functionality. And the last thing is the BIM collaboration format, okay? We use these a lot in the vertical world or the building side, but they're coming into prevalence as we move towards infrastructure and horizontal play. The benefits of BCF are that exchange or the class detection or the rules detection or the hierarchy that is there inside of your model construction. The sky is the limit for what you can do with a building check file. And that's a very important part of validation and QA/QC of utilizing openBIM. So here's an example of a check file, just the header, the start of what you need to do as you build it. And again, there are samples that you can do. You can get them from WW3, but to build on various XML schemas. This is an older example of a platform that I built to check files and what was there. Again, it's thousands of lines of code, but the difference is when you have an understanding and you know what you're looking for to check for clash, model integrity, geometry integrity, data integrity, building check files are key, and something that I highly recommend in the use of openBIM. So with that, we're going to go into some more specific schemas. And Uniformat 2, while many people think of it as just a building schema, it does have civil or horizontal works that are part of that schema. What I'm showing here is related to buildings, but we have the Uniformat table, which is broken down into very short form. It goes out 5 levels, but depending on how deep you want to go with how you're developing what you're doing, it ties over into what's shown on the right, where you have space, category, family type, and instance level. These vary by software, but the format and the schema can then be broken down even further into OmniClass, which is another established schema that we work into our XML documents. So Uniformat is a container. OmniClass becomes the element level definitions of how we want to define what we're doing based off of the various tables that you see here, which can all be downloaded in CSV format and then translated into XML schemas. This is where the two come together. So when we tie OmniClass and Uniformat 2 together to container to element level files, it's a great schema to work with regard to XML and how we're developing what we're doing. So I encourage everyone to look into these schemas if you haven't, because they're very powerful to contain information with result of openBIM and the interoperability between software platforms. And then obviously we have the LOD forum, LOD spectrum here, where LOD is required, and those building check files come in very key here when you're talking about LOD and validating your models throughout the delivery process, whether it's existing conditions or new designs based on openBIM schemas. So here at AECOM, I've developed 8 touch points, or what I call 8 pillars of BIM to asset management. And the reason why it matters is asset management is the end goal, right? That's what we're trying to achieve. We have conceptualization in two forms, scratch point and vector. Those are the traditional two-dimensional files that can be data rich if you develop the right schemas and the P sets for those objects. But then we really start to cook whenever we go to 3D or the spatial forms, which then tie to the fourth dimension, which is implementation or time and schedule, and then the 5D, 6D, 7D, and 8D. And one of the things that I want to stress is schemas can also represent risks because of tools like Power BI and the emergence of AI. Risk can be analyzed through various theories or algorithms through the uses of openBIM if you're creative and thoughtful. All of the items that I've listed are things that we typically include in our models so that that data and information translates through an openBIM forum. So what we have is called a data lake. And what we do is we take and collect unifying data from multiple sources. We integrate it into a database, and you see IFC is the core of that. And then we go into analytics, queries, and dashboards, how we can get better outcome from the digital assets that we have. So the benefits of openBIM at work. openBIM allows for interoperability between disparate software platforms. It is agnostic. So software, many of them, hundreds of them, can assume the amounts of data based on open APIs and view the attributes or the elements of the model. Ownership or chain of custody is important because the ownership of the elements are maintained throughout the life cycle, and each iteration of an openBIM model lock down features and their parameters and attributes. They follow ISO standards. I cannot stress that enough. We don't have time today to go into all the linking ISO standards, but there are about 24 that are connected together that go into creating a very successful openBIM. And then the schemas can be customized to fit the needs of the end result, which I talked about can be XML or JSON. So proposed enhancements. What I found are 5. openBIM is still in the infancy stage for global adoption. More agencies need to develop an understanding of the power of openBIM and the business use cases. This is important. Terrain modeling requires enhancements. Large terrain models do not produce correctly because the size and the amount of triangles to make the surface. openBIM schemas need to take asset management into account as greater detail. ISO standards define this, but as we're moving towards digital twins, asset management has to be paid for in those schemas. Standards need to be implemented across agencies that use black box software. We encounter this with various numbers of clients. They have their own software developments or requirements that are not open schemas. They need to adopt and develop open schemas to share and utilize that information. And then finally, we need vendors to develop a stronger schema for 4.2 enhancements for civil works. I've been working for quite a long time to get civil works into our IFC schemas for the models that we do in transportation. So I'm going to go real quick and switch my screen. I'm going to stop sharing here and switch over to Celebri, and then I will close out and then turn it over to Connor. I hope everyone can see the screen. I can see it on my end that it's being shared.
Looking good.
This is Celebri Office. Used to be thought of as Celebri Model Checker. But the great thing about this is what we can actually do inside of Celebri and how we work with openBIM models and IFC schemas. This model comprises several hundred models. It's a large transportation project, and it focuses on SUE elements inside the project. So the great thing here is I can check my identifications. my IFC file descriptions, which are very extensive, and then the implementation level for the schemas, the file name, where the software that was used to derive it, the time and the date, other information, the file schema that was used, and then any hyperlinks to objects that I would click on. The benefits when I talked about the expanded schemas is when I select objects inside of this model, the P sets or the additional IFC schema information that I wrote in XML comes up and identifies all of the relevant properties that can be used or exchanged, mostly going downstream towards asset management softwares. We can get quantification, which I think Connor's going to talk about. We have relationships. We can also go into custom properties. For this instance, we had information from the field on install date, install time, the number of the rings. This is a dewatering tunnel schema that was set up. And then the station identification and IDs. So it's a very powerful tool. It's a very integrated model, but you can see with the proper schemas and identification that there are other checking tools out there on the market, but you can see that there's great opportunity if you set these schemas up and build these models properly, that you can check them with rule sets, and those are also P-set definitions or BCF file checks, which you can connect here, import your own information, or create them. And there's a lot that you can do with openBIM and the information that's available. And with that, I'm going to stop sharing and turn it over to Connor.
All right, thank you. I will share my screen. And start presenting. Of course, I'm sharing the wrong screen now, aren't I?
Yeah, we were seeing your speaker's view.
Yep, let me switch that over then. Put this over here.
Thanks, Connor. And while you're doing this, thanks for joining us today. We really appreciate your putting together this material and especially addressing a complex subject in a way that we can all sort of understand what you're doing. So that helps. And yeah, we're seeing the correct presenter view now.
Better. All right, thank you. So I'll be talking about openBIM and quantity takeoff, or QTO. Going to go through a quick introduction. I'm going to go through an overview of kind of QTO and how we're thinking about it, what our current methods are, and how we are trying to implement openBIM to get past our current methods into something more advanced. So a little bit about myself. I am Connor Christian. I am the Kiewit BIM operations manager, and I've got roughly 20 years experience. I say about half of that was in construction, working as a project engineer and superintendent, building pretty much everything. I'll just leave it at that. But the other half of my career was very much about BIM, either managing BIM for companies like Kiewit, or doing some sort of BIM consulting. I worked as a BIM consultant for a while, or actually working in software development. I worked for both Innate and Procore, developing BIM products. Right now, I want to talk about QTO. This is the quick overview of how we're thinking about it currently and what we're trying to achieve with it. What we really want to do on our projects with quantity takeoff is make sure that we are checking in on our quantities on a regular basis. And this is really important because quantities are really everything, particularly in our transportation projects. And whether that's in design or in construction, quantity takeoff on a regular interval is very important. And I'll focus kind of on the design side right now because a lot of our projects are big design build projects are seeing a lot of benefit here, which is that when we're taking quantity takeoffs from our model, we're able to see change happen more regularly. We don't have to wait 3, 6 months for a set of drawings to come out, only to check the quantities and see that they changed. We're able to get updates at right now. We try to do it about every 2 weeks. And so what you see is that we're seeing regular change. This is a very small example that I threw up on the screen here, but it shows, some vertical form concrete and how that's changed over time. And you can see that the counts change, the lengths change, the areas change, the volumes change. And you can drive into that data and see exactly which types of walls are changing. And all of that can be understood well in advance, again, of any sort of package being delivered. They can also be checked back against forecast, seeing, like if we have a forecast amount, we're expecting so much cubic yards of concrete in our walls, we can actually watch our models as they build and see those quantities approach a forecasted amount or pass a forecasted amount, so that we can start asking questions. So that is really our goal, is to make sure that we're monitoring how change is happening, so that there's no surprises when new packages are delivered. Now, a big part of quantity takeoff is the classification. In order to actually get those numbers out, we need to understand what objects are and how they're classified. And for us in particular, it's our work breakdown structure codes that we're trying to apply to those objects. And there's always that fun game of trying to marry up, okay, what is it named versus what is its account code? And I'll talk a little bit about that method of how we try and make those two things work together. Now, there's also a unique problem in QTO, which is that there is a one-to-many problem. If I have one object, it would be nice if I was only trying to get one thing. I have a concrete wall. I just want to know how much concrete's in it. But that's not really the case. As a contractor, we're a little more, go a little more in depth into our estimates and want to know more about our quantities. So our one object, like a concrete wall, not only do we want to know how much concrete is being poured, but we also want to know how much dry finish has to be applied. We also want to know how many joints there are. We also want to know the square footage of bulkheads and formwork. And all of that is actually a whole bunch of account codes that get applied to just one object. And so it's not always as easy as I have one object and I just get quantities out and it does what I need it to. And I'll talk a little bit about how we approach that problem. And this is something that I talked about, going back to a forecast or going back to something that we can compare it to. An important part of that is actually trying to just come up with a primary quantity. I mentioned the one-to-many problem. A lot of times we'll choose just one primary quantity that we are kind of tracking for forecast. And that's more of a database issue, because a lot of times these things get named similar or different things, and that makes it hard to compare across all of the different objects that you look at. But if you have, for each object, have a variable that's called like primary quantity, that becomes something that is able to be compared easily. And that's really just for reporting purposes. That's kind of something I like to throw in there that we're doing. Not only are we getting all that data and trying to figure it out, but we like to identify these primary quantities for comparison purposes. So that's the overview. Now, the current method in how we're approaching this is, I talked about classification, and that's really the first step. Currently, what we are typically doing is, after our models are created, we're actually having to start to apply all of these, account codes. And that's just kind of how it's been currently. I would very much like to say that, we're getting all those account codes applied properly while we are building our models. But the truth is, a lot of the projects get started up and are rolling before we're actually able to get in there and talk about this process. So what we're left with most of the time is models that after the fact we have to apply it to. And that is problematic. It's actually pretty tough. It's to apply those account codes. What we're doing is we're taking our current models, we're bringing them into a platform, Navisworks. We're actually tearing the database out of that and applying our account codes to those objects in that database. And that allows us to partially automate it. So there's some things that we can see about objects where we're able to, say, this thing gets this account code and have it, read through and do that. But I'll say that a lot of it is actually manual. You have to go through and find those objects and try and figure out exactly what the account code is that you want to apply. But once we've actually applied all those account codes into this database, we're able to push it right back into Navisworks, where it shows up as its own kind of tab and piece of data applied to those objects. Really important though, you got to figure out what your objects are and get them classified. Now, once objects are classified, we're able to do quantity takeoffs. And right now, the current project or product that we're using is Navisworks to do that. There's lots of products out there that you may be able to use. We've leaned towards this because it helps us solve our one-to-many issue. In Navisworks, you are able to create a takeoff on objects and assign that object resources. So I can take off one wall, and not only will it take off the wall, but it will take off the formwork, and it'll take off the joint prep, and it'll take off the dry finish, all of those other pieces of that wall and associate it back with that object. And that saves us a lot of time instead of having to take one item and take it off, 8-10 times. I take it off once and it does, 10 takeoffs for me. But in this process, again, it's mostly manual. When we do our takeoff, we create search sets. I select an account code. I find the corresponding account code within my quantification workbook, and then I hit takeoff. But that is click here, and then hit takeoff. And every time it changes, someone has to come back through and do those clicks for every single account code. Now, once that quantity takeoff has been created, what we do is we export that out to Excel so that we can attach that data into some Power BI dashboards that give people the readouts that they need to track those changes in quantities. Now, I'd love to say that that was perfect too, but even that is an issue. And there's something really important to note there, which is when you work in like Navisworks, it has a great quantity takeoff tool, but it actually starts to take the data out of the objects and put them into a workbook. So the quantity takeoff workbook is an entire separate data set from the actual modeled objects themselves. And that is one problem. The other problem is upon export, I mentioned that it does this thing where it has the regular takeoff, but it also has those resources, those other objects like dry finish and erect and strip forms, or you can see over here, fab forms, erect and strip forms. The problem being, if you look over here, the account code 6103.10.002 is the same on all of those. Now our resources actually have another digit in there. After that 002, there should be like a 0.01 or 0.02. And for whatever reason on export, it doesn't get applied. It only gives it the WBS of the overarching object. So that's problematic. So there's lots of issues we have in these exports. While we do get good data, it's not giving it cleanly to us, and it is not actually allowing us all the data that comes with the entire model data set. Because, for example, here you can see it gives us like the WBS breakdown, but it only allows one quantitative property to come along with that. And if we're doing something like pipes, and I want to try and differentiate my pipes by their material and by their size, that's not data that I can pull over. I have to choose one or the other. These are all issues that we're having right now And this is very specific to this tool. But there's other ways that we think that this can be enhanced and will be solved when we start to use more of an openBIM method. So internally at Kiewit, we are working on our own kind of software tool that would be for Kiewit only, but we are using it, and it's going to be very much based in openBIM methods and IFC. And it's something that we're actively working on now, learning from these issues that we're having with our quantity takeoff tools. We're leaning into what can we do better. So I'm going to take you through what this openBIM method kind of looks like and why this is a little better. Now, ideally, in our future projects, we're actually applying classifications and IFC classifications and our account codes in the models as they're being created. It's not created, not something that we do after the fact. That's something that is built into the softwares, works fairly well, and it's going to carry some of that data in for us, and that would be helpful. But even if it doesn't, our tools are planning on leveraging a more automated process where we're going to search for account codes and enhance data, which is going to be fully automated. It's not someone looking for something, clicking on it, and then clicking on something else. And this is where openBIM is so important. When you know that something is predictable, you're able to program it. And that's what's great about like the IFC data schema. And what you see here, for example, is for a drainage pipe, what some of the parameters are in a P set. And what we can do is, as the model comes into our system, it automatically is reading things like, what is our Kiewit account code, or what is this IFC classification, and is making sure to go out and grab the things that we know exist and make sure that those properties get to where we need them to be, like a diameter or a material or anything else. And so our object data gets a lot more enhanced and is a whole lot stronger by having a process that is predictable. And once we're there, once we're just bringing in models, having it automatically apply our account codes, or search by account codes, or search by classifications, and add in all the extra data, at that point, all we're doing is taking reports. So the hard part that we're working very hard on currently manually is done programmatically. And then we're just creating reports. And those reports, unlike our current softwares, those reports are actually going to be everything that we need. And it's going to be on the same object data set, not a separate data set, so that we can actually sort it and group it as desired. If I wanted to, look at these objects and, change the size and group it by size, that would be something that we could do. Or if I wanted to group it by a certain account code, that would also be something we could do. But it's all in one big data set. And after that, we would either export to Excel, or ideally, we're going to connect it directly to our estimating or quantity takeoff softwares. So in summary there, the advantages from what we're doing today to what we're trying to do with our openBIM QTO process is we're trying to create more automation in the application of account codes, the application of qualitative data. Having that process be automated is much simpler in a world where we know what the data schemas are. And that's why that's so important, because we have projects that are in all kinds of softwares, Bentley and Autodesk and Nemetschek. And if we're able to bring them in and get them all normalized quickly into our QTO process through a known data set using openBIM, that is a huge advantage for us. The next advantage is that there is more data. there's, I mentioned that we have that issue that it's when we're going from our models to our takeoff softwares, a lot of time what it's doing is it's transferring some data to a new data set. And that actually makes things more difficult. The programs think they're making things more easy by reducing the data into something else, but that's not the case. So just working, in openBIM allows us to work with an entire model-based data set so that we don't get limited on the amount of data that we're working with. It's also more organized. We're able to sort it and group it in any way we want. We're not limited to the work breakdown structure that we originally set up. Sometimes you just do need to slice it a little bit differently. But sometimes you need to look at it in the WBS. Having the ability, when you have all the data in your hands, in your control, you can look at it in different ways. And then, my favorite part is that it's comparable. When these data sets are normalized, when we're using IFC, the data becomes comparable between versions. So it's very easy to track how quantities change between versions, but also between models, between projects, so that we can start to make, comparisons on how projects tend to change and how they might change and how they compare to one another, and really start to understand our data in a more global way. And so I think with that, that is all that I have prepared. But I think the end of this, we're going to open up to questions.
Yes, thank you, Connor and Michael both. And we already do have some questions coming in. One of them is specifically a question for Connor. How are you updating and what quantities as these are being installed? This question comes from Alvaro. And actually, would you like to voice that over yourself? We can unmute your microphone if you'd like. In fact, we've done so.
Hello.
Yes, we hear you.
Yeah, thank you. Connor, thank you so much. I thoroughly enjoyed your presentation, but and I don't know if this is the forum or not, or maybe we can talk offline, but quantity takeoff is definitely something that's the lifeline of a project, right? You have to know how much you have to install, and then being able to track what has been installed and forecast what's left to be installed. But how do you update the model on a regular basis? What are you using to update the model? I mean, from the field to the model? That's what's intriguing to me on your presentation. If you can elaborate on that, I would truly appreciate it.
Yeah.
Thank you.
So, yeah, thank you. Yeah, so most of the, I'm going to talk about it in two ways, because there's the, how do we deal with, what's changing during design? And during design, we're basically just taking the model, and when we save that data off, we're date stamping it so that we can see how it changes by date. And so all of that data about the quantities gets put in the same place. And that is one way that we're able to indicate change. Now, when it comes to what's going on in the field, I'd love to say we have a much more automated process at this point, and I want to get there. But right now, it's still, you go out in the field, you use the current field tools to collect what you've actually put in place, and then we have to compare that back to the forecast from the model. But that the data collection is not as seamless as I'd like it to be. I'd love it to be model based, like you go out there, you click on a wall and say this was installed today, and then it just changes the quantities. But that part is still more of a manual process at this point.
Thank you.
Yeah, that's great. Thank you. And Alexander, we noticed that you had some questions which Michael has already answered in text, but wonder if you would like to voice over some of those. Um, I'm sorry, it's taking me a moment to find you to unmute your microphone.
Hey, thanks for that.
Oh,
So
yeah, there we go.
can you hear me? Okay,
Yeah,
great.
we can. Thanks.
The first question about the asset information model, Michael did a great job answering it. That was helpful. But I did have, maybe some requests for some additional information regarding certain quantities that seem like they're more difficult to count using a 3D model. And I'm just kind of curious what strategies you might have. And I'm thinking, things like waterproofing membranes where you're costing it out on a square footage, but you might be, representing this with like a very thin 3D element, or things like a wearing surface that is only applied to certain parts of a deck. Do you go ahead and model items like that, or do you somehow try to embed that information in other 3D objects? I'm just kind of curious, when you have these things that are difficult to quantify, what strategies you use to actually calculate or, derive that directly from a modeled object.
So I can fill that one. What we do inside of our BIM models is create formulas, and the results of those formulas are reported out in IFC schemas. So we're not necessarily modeling all of the elements. We try to model major pay categories or elements that matter for QTO in major quantities. The things like waterproofing membranes or thin coat wearing surfaces or asphalt rehabilitation are done by formulas. And those extractions can come directly from the model, from the calculations, if you write the IFC schemas correctly with a P set, to go out into where you're taking that. CSV is very strong as a format for transfer. Again, my preference professionally is XML because it carries an extensible amount of data, and Excel works off of XML, as does Word and a lot of the other Office programs that we use.
Okay,
Yeah,
thank you very much.
And to add on to that, I very much agree. We add formulas to it, and that's really exciting to me because when it comes to trying to take quantities or make estimates, the way it's always worked in the past was you have a set of drawings. They're not perfect. You do some takeoffs. You apply some equations to make those takeoffs a little more perfect to get to your number that you need. And those equations that you apply to get your takeoffs to the right place have been based off of drawings for so long that what happens a lot of times is people try to get those quantities from a model and plug them into an old equation that really is for drawings but not for models. And so I encourage anyone who is trying to build those equations into their models to understand like you said, waterproofing membranes or joints or whatever. Look at your models, analyze them, and come up with those equations that fit, because they're probably not going to be the same ones that work off of drawings. And only when we start to work out what those equations are, do the real value of model-based quantity takeoff really start to take off.
And Connor, have you noticed intelligent PDFs in Solibri? It can take PDFs. And if you generate intelligent two-dimensional PDF drawings where that information is derived off of those drawings, it carries with it the metadata. And what we found is with a tool like Solibri, it can read PDFs. And when you select or click on the objects in the hierarchy tree, because of the schema that you sent out, that data actually shows up. So there's a lot of ways to tackle this.
Just one additional thing, if I could add, Connor, you saying that a lot of these quantity takeoffs are based off of, some older ways of deriving values using drawings. Do you see any DOTs or other agencies that might be changing the way that they quantify some of these to reflect a more model-based design? Or are there some concerns? I'm thinking things like it'd be much easier to measure a concrete barrier on the edge of a bridge using a volume attribute. But if they're inspecting in the field and checking how much has been actually constructed, the linear foot measurement is still very convenient for a construction inspector.
Yeah,
But
no,
you-
I've not necessarily seen those changes taking place.
Okay.
But that I believe that will be driven, honestly, though, the way so many things are, by conflict. One day someone's gonna see it and be like, oh, this doesn't work at all. Um, and they'll change. But I think that's just a matter of time.
What I've
Understood.
seen is there are 27 DOTs that are in movement right now towards model as legal document. And basically they're moving away from 2D traditional plans and to models as that source of truth that I spoke about. So I hope you don't mind me adding on here, Connor, but my research has indicated that the use of openBIM is getting widespread, particularly with regard to DOTs. They're considering it. They're moving away from previous methods of accepting or adopting information and using the models for that final quantification. The project that I demonstrated, for example, was a life cycle project that started from design for class detection, quantification, scheduling, other things, that moved its way into as constructed. And we have about 20,000 models total for the project over time, based off of information that was done during design phase deliverables or actual constructed phase execution of the as-built that were validated and then updated inside the model.
Yeah, I completely agree that the DOTs are moving that direction. So again, that makes it just kind of a matter of time before, some of the new methods start to cause conflict with maybe old process.
Great, thanks. James Satowski, you had a question about the QTOs. Would you like to voice over that question?
I can, certainly. Quick question on when you said you had to cycle back through all the model every time your quantities changed in one area or another, and that process was repetitious and lengthy. It strikes me as that be something that could be scripted. Was that ever tried?
Yes. So there, with some of our current methods and techniques and tools, it's been, to put it simply, not possible. We have tried to script as much as we can. And this is where things like openBIM are so important, because one of the projects, I had some images in there, but on this particular project we have 200 modelers, and the truth is, and that they're from different companies, and everybody's got kind of different standards, and they put data in different ways, and when you don't know what you're getting, it becomes very hard to program. That's why IFC and these standards are so important, because if everybody was, delivering me an IFC model where everything was, put right into the schema the way it should be, I could program everything. It wouldn't even be a thought. But right now it's still kind of the Wild West out there with people who are developing models, and you got to try and get everybody on board. And if you can't, then you got to do it after the fact. And sometimes when you don't know what you're getting, it becomes too hard to script.
We have a question that was demurely submitted anonymously, but it's actually something that we think might be on the minds of many of the people in the audience. So we'll just voice it over for you. Great insights from both presenters. Question: how do we start taking models toward openBIM? What can be our first step if we are currently having just a model without any standardization applied to it. Any advice for resources would be great.
Sure, I'll start. ISO 19650. There's three parts to it. It's not commonly adopted in the US, but it is something that I recommend. It's an international standard. It's used everywhere pretty much except for the United States. Because as I talked about with the black box software developments that agencies use here, it's a little bit more complicated, but FHWA and AASHTO are moving towards recognizing ISO 19650 standards. The other thing that's important there is the difference between a project information model and an asset information model. They're two completely different deliverables, and they have different intents. And that will give you a guide as you're writing your BIM execution plans to set up models that can be agnostic. And as I said, always start with the source. So every vendor has the information that I presented about XSD, XML, JSON, PSETs. You can search for those, find them, get a basic understanding. There's simple tutorials on LinkedIn to get a basic understanding of how to work with the code. Work inside the code you're given, save those out, build new classes, things that are important to you, and tie them to your models. And definitely follow the IFC schema definitions, and you can learn how to build custom IFC schema definitions. There's some great information on LinkedIn and YouTube about how to do that, that when you export your models from your native software, you can enhance the schema by adding your information into that schema before you export the model.
And my recommendation would be to really try to help the folks that are working on building models, help them lean into the idea that the data is as important a part of the deliverable as the way that it looks. Because most of the people in our industry who generate models and drawings have only been focusing on the drawing as the product. And so the data gets neglected. It gets messy. And it's just because nobody necessarily had to make sure that it was good. But once folks are realizing that the data and the properties and the parameters of every object that they put into their model is very important and is part of their quality process, things are going to get a whole lot easier. It's going to be easier to create IFC exports and use openBIM methods because your data is going to be a lot cleaner. But until people start really leaning into the idea that that's their responsibility, that that's part of their work, it's going to be hard to get good data out.
Good. And although we've reached the top of the hour, Jonathan has a question about IFC and openBIM in roadway and civil. Jonathan, would you like to voice that over for us?
Yeah, just that. Is anybody in this environment, has anybody begun to implement IFC designs or objects in like an openBIM workspace within a roadway or civil? I'm on a roadway side, and this is something that we're kind of just now starting to look into. And there's not much out there, at least from what we've seen so far. People that are trying this, that are doing this in roadways. So I'm kind of looking to see if you guys or if anybody here has any insight into that, because from what I'm perceiving, that this is a very large shift from traditional method to this style model. So.
Well, we're at the top of the hour, but I can tell you, Jonathan, if you reach out to Building Smart, they can share my information. I've been working on that a lot, and we're collaborative as a company, so I can share some tips or tricks or schemas about how we've worked out the new developments for IFC. And it's open information. It just helps us better in the industry.
Yep, and my quick answer is the IFC 4.3 schema, which incorporates, transportation elements, has become or was accepted as an ISO standard recently. It's being built into, that particular IFC schema is being built into the softwares, the Bentley softwares, the Autodesk softwares. They're picking it up. So I'd say you are correct in that it's relatively newer, at least in the sense that it wasn't always well defined, and that is something that I know that I am working with to try and figure out some of the early ways that we can work with IFC 4.3 and make those deliverables a reality. But it is newer and something to look out for.
Well, that's
Yeah.
great. Thank you very much. Unfortunately, we're at our time. We know that there are other questions, and we're sorry we haven't had a chance to address them, but please email them to Building Smart USA. Janice will give us the correct email address. Janice, if you're able to show that on screen. There we go. It's in the chat window, usa@buildingsmart.org. We will make sure that your questions get to the speakers and give them the opportunity to get back to you. So thank you very much, both Connor and Michael, for a great presentation today. And this will be available in a recorded format. Have a look at our website in a couple of days. So thanks much, everyone, and wishing you all a good day.
Thank you, everyone.